Metal forming process. There are few metal forming process which we discuss. One is rolling, next one is drying. It is two types. One is wire drying, another one is tube drying. Next is extrusion, fourth one is forging. These are metal forming process on a solid metal. There are different other operations like sheet metal operations which we will discuss. These are first metal forming process where there is change in shape of the metal because of external force. The first one, rolling. Rolling, the objective of rolling is to produce thin sheets. So the thickness of the sheets is reduced by using two rollers. The sheet has to be passed between two rollers such that you have to apply a force on the roller. It can reduce the thickness of the sheet. So material compressed between two rotating rollers. The rollers has to be of same size. That's the first condition we need to take. Otherwise they will deviate. The strip which is coming out will deviate. So this one is initial size of the strip. Final size of the strip. These are the rollers. Rotation of the rollers. H0 is the height of the metal strip before entering into the roller, before rolling, height of the strip after rolling, and V0 is the velocity before rolling, V1 is the velocity of strip coming out, V is the velocity of roller. So these are the parameters which we need to remember. R is the radius of the roller. So strip can be pulled into the rollers by friction acting between the rollers, and to get the straight strip of the roller, the velocity should be constant. To get straight strip, the velocities to get the straight strip of the rolled component, the velocities of rollers must be, so velocities of rollers must be equal. V1 equal to V2. We know that velocity equal to pi d n, and diameters has to be same. So to maintain equilibrium, so this equation why we are doing is to show that diameters of the rollers has to be same, such that speeds will be constant. d1 by d2 equal to n2 by n1. n1 equal to n2 if d1 equal to d2. So always in rolling, diameters has to be equal. So point where the strip started contacting the roller is called entry point. Point where the strip separating from the roller is called exit point. Entry and exit point. Angle of entry and exit points with respect to the center of the roller is called angle of bite. So angle of bite or biting angle or deformation angle, different names which they will call. So if we look at the diagram, same diagram, if you draw a line here, so this is O A B C. So A is the entry point. A equal to entry point. So this one entry point. B is C is the where it is at the middle of the actually it is exit point. It is not showing properly here, but C is exit point. So angle of alpha, angle of OAB is alpha, that is called angle of bite. Angle AOB equal to alpha. So the angle angle of entry and exit point with respect to center of the roller. Angle of entry and exit points with respect to the center of the roller is called angle of bite or biting angle. Or deformation angle. So in problems they may ask with different names, that's why I am giving all names. It's better to know all the names. So delta H, H0 is the initial thickness, H1 is the final thickness. So delta H is equal to H0 minus H1, which is a change in the thickness. So assumption is width of the strip remains constant, only length will change, height will change, height and length. Width of the strip remains constant. So volume of the material before rolling is equal to the volume after rolling. So from triangle OAB, cos alpha equal to OB by OA. So what is OA? OA is nothing but radius of the roller. What is OB? OB is nothing but radius minus delta H by 2. Cos alpha equal to OB minus OB by OA equal to OB, you can write it as OC minus BC divided by OA, that is equal to R minus delta H by 2 divided by what is OA, R. So if you simplify it, you will get delta H equal to D into 1 minus cos alpha. So which is one of the important formula for GATE questions. So if it, in the same way, similar manner, what is the AB in the diagram? AB equal to length of the deformation zone. What is AC? AC is arc of deformation zone. Sometimes, once they asked in GATE in 2 marks problem, arc of the deformation zone. So you have to find out the length of the contact of the arc, L equal to R theta. So that's why AC equal to R into theta. Theta is nothing but alpha, that one, angle of bite in radians, pi by 180 degrees. Okay. So similarly, from the same diagram, AB equal, you can write it as OA square minus OB square. Okay. If you want, I will draw the diagram again to understand it properly. Understand. This is a roller and strip. I am not drawing entire diagram. Just have a look at how it is simplified. O, A, B, C. So this one is alpha. So from the triangle OAB, AB square is equal to OA square minus OB square from the trigonometric concept, Pythagoras theorem. So what is OA square? OA square is nothing but R square minus what is OB square? OB square is R minus delta H by 2 whole square. Simplify, if you simplify it, you will get R delta H in bracket neglecting delta H square by 4. So AB equal to R delta H. AB is nothing but length of the deformation zone, that is equal to L equal to square root of R delta H. So most important formula. Similarly, from the diagram, tan alpha equal to AB by OB. It's nothing but AB is length of deformation zone, R delta H divided by OB, R minus delta H by 2. Simplify it, you will get delta H equal to R tan square alpha. Neglecting delta H by 2, so delta H equal to R tan square alpha. Neglecting delta H by 2 values. So maximum angle of bite is 90 degrees, but it is never possible. 90 degrees means nothing is coming out, so it's not possible. So angle of bite will be ranges from 3 to 34 degrees range, depending upon the material. For soft materials it will be higher, that means you can reduce a lot. for hard material, if you are not able to reduce the thickness, so the angle of bite is small. So velocities, V1 is the output velocity, always higher than the V is the roller velocity, V0 is the input velocity. So the velocities are in the decreasing order. V1 is the output velocity of the strip after rolling. V0 is velocity of strip before rolling. V is roller velocity.